Sagar, I'm audible?
Yeah, Jameer, you're audible. Yeah, no problems.
Okay, yeah, thanks. So I welcome everyone, all the participants of refresher course and the summer school students. So today we'll see a few presentations on the experiments from the teachers and any students from the summer school, if they want to show their result and share their experience, so they are they are welcome. So we'll take first few presentation from the teachers, and by that time, if any students, if they want to share their work and share their experience, please drop a message to me here in chat box. So I will select few of them and we will see. So, and I hope all the teachers are ready with their presentations. So as far now, I have received 6 response from the 6 group. So I didn't get any response from 4 group, and still they want to represent their work. You can message me, and we have time. So like either by oral or by presentation. It will be better if they have presentation, other by oral, it's okay. So shall we start? Second, shall we start?
Yeah. You're the boss. You're in charge. You go. Maintain the time limits. Otherwise, it will become too long.
Yeah, maintaining. So I guess they know, they can present, they can talk for 3 to 4 minutes, and we have 1 to 2 minutes for the question and answers. So we'll try to finish in 5 to 6 minutes maximum. So we're please make sure that you should not exceed the time, because we have 6 to 8 at least presentation today, and we have other announcements also and other activities also. So I request everyone, please, those who are presenting, keep a track on time and keep eye on time. Even I'm keeping an eye on your time limit. So we'll start with one by one, one group. So is Naveen Gaur is there from RCAA at one group? Naveen? Is Naveen here?
Okay, I'm there. I'm here.
Okay, great.
So you have to. Yeah, sorry.
Are you ready with presentation?
Yeah, I'm ready with the presentation. Shall I share my screen?
You should be able to share your screen.
Okay, just give me a minute. Is this visible?
Yeah, we can see yours.
Okay, so let me. I also have a query, small query. Should we upload this presentation in our that page which has been given?
So you can upload, as well as you can mail this presentation to on email. So nrc@gmail.com.
Yeah, the question was that actually because we have to also give a report. So the 2 submissions, will it allow or not?
You already prepared a presentation, I guess.
The presentation is there, but presentation and a report also has to be submitted later.
Yes.
Maybe I can answer, Jameer. Sorry.
Yeah.
So if you're talking about just the file, this file, I don't think you need it in addition to the report they're submitting, right, Jameer?
Okay, that's fine.
As long as they have the report submitted there, I think it's fine. As far as the presentation goes, we have this video for reference anyway.
Okay, thank you. So may I start?
Sure.
Yeah, go ahead.
Okay. Sure. So this is on behalf of RCAA at one group, and the participant list is already given over there. Many of us, actually nearly all of us, have tried to work out these experiments, and finally the results or the setup which I am showing in this presentation would be by the first person, ISSAA. Finally, that's what we have decided that we'll show the results of. So I'm presenting on behalf of all of us. The authors' names are there. So let me start off with the first experiment, which was the effect of putting a reflector at the back of the antenna. And this was the setup which was already explained. I will not go into the detail of this. This is already explained. So let me straight away go into our results. We have carried out this experiment. And this is what the setup which we have used. On the left-hand side, you can see the photograph. We have used a mobile phone, a laptop, obviously a measuring tape. And for the reflector, we have used cardboard, which is covered with the aluminum
Dr.
foil.
Gauri, I think your slides are not moving.
Yeah, I don't see a change in the slide.
I don't.
Now it is moving.
Yeah,
now you, okay. So it maybe it's the full. So is it? Can you see this now?
Yeah, we can see.
Okay. So this is the first experiment, and this picture is actually taken from the manual which was provided to us. So I'll not go into the detail of this, but let me show the setup which we have used. The setup is, the picture of the setup is given on the left-hand side, and what we have used for this whole, both the experiments, the same mobile phone. And then for the reflector, what we have done is we have used a cardboard which is covered with the aluminum foil, which can be seen in the picture, and Windows operating system, a laptop with Windows operating system, and with tumbler for measuring the signal strength. This is our results. And for these results, what we have done is we have used the capital D, which is the distance between the mobile phone and the receiver, which is the laptop, to be about 1.5 meter. And this is the plot of the power versus the distance. These crosses are basically our data points, and we have also tried to fit it with a curve. I mean, probably one can do even better, but this is what the result comes out to be. So this is the result of the first one. Let me just quickly move on to the second one, which is the verification of the inverse square law using Wi-Fi signal. And again, this picture is taken from the manual which was provided. So I'll again not go into it because it hasn't discussed. Let me show the setup. So it's the same setup which we have used, same hardware, same software, but we don't need reflector over here. And finally, let me just present you with the results of this. So what we have plotted over here is on the x-axis, we have plotted the log of distance, and on y-axis, basically the dBm, which is basically log of the intensity. It shows the reduction in the intensity. And this graph, as expected, is almost lying on a straight line. That's what probably was expected with a slope of a negative slope. So that's what it is. I think I'm through with the result, and we'll be going to submit the report by 12th of June, which is the deadline. Thank you.
So, what would be your comment on the reflector measurements?
Well, there was a problem. So this is the results of the reflector measurements, and as you can see, the data points are scattered everywhere. I mean, some of us actually, I mean, the results which are presented over here are by using Windows OS and WinTumbler as a software. But we have also tried by 2 mobile phones. The problem, actually the uncertainty was even bigger when we used 2 mobile phones. So when we use Wi-Fi analyzer to measure it, we found that even, I mean, the points were even more scattered. So, I mean, I don't know what is the reason. It could be the reflections which are coming from other places also, or, but I mean.
Yeah, converting this to linear scale might show you a better correspondence with the sinusoid than log scale to, you know. So just try that.
On y-axis, basically, you're saying.
Yes.
Okay. Because
Because the null is not represented very well. It will be like a notch in the log scale, right?
Yes, that's true.
And so it's a slightly distorted version of what you would expect in the linear scale along
Absolutely.
So you might find it more revealing. Okay.
Okay, we'll try to do that. We'll try to do that and probably put it up in the report.
Okay, thanks. Yeah, that's great, I think.
Okay. So is this fine? Should I stop sharing it or?
It's fine with us. And
Okay.
If any other comment and if you have any doubts, so they can ask.
I think
Ashish? Okay. If there are no questions, then okay, thanks.
So I'm stopped sharing my screen and
Yeah, you can stop.
Thank you.
Just
Thanks,
an additional in passing that
just
as you increase the distance, the reflections are not as good as they would be when the reflector is nearby, and you would see the effect of that as you increase the distance. Okay, so there will be an overall reduction, slow reduction. Okay, on top of the oscillating behavior.
So basically, what you are saying is that the oscillatory behavior will dampen out and will just.
Yes, for example, you can imagine that if the reflector kept very far, it will have not much effect. Correct?
Of course. Thank you.
So Naveen, one question.
Yeah.
So was there any difficulty while performing this experiment?
Yes, in the reflector one, yes. As I said, the data points even over here are a bit scattered. And when we were trying to match our results, then some of the data points were really very, very widely scattered actually. So finally, as I said, that we have over here, I have shown the results of one of us, the first author, IUCAA, but all of us had our results. This is one thing which we found would to be the best ones.
Okay. Good. Thanks, Naveen.
Okay, thank you.
Yeah, the next group is IUCAA Stella. Priyanshu Grana. So are you ready with your experiment? Presentation. Is Priyanshu here? Just check.
Jameer, you'll have to unmute them, I think, because they may not be able to unmute themselves.
Yeah, because parallelly I'm also replying to some of the chat. Yeah, Priyanshu, you're now co-host. So you should be able to share your screen as well as you can unmute yourself.
Okay. Yeah, I have unmuted. Can you hear me? Am I audible?
Yeah, you are audible.
Okay, thank you, sir. So,
just a second. The next group is Sun Star. So Priyanka Patel, be ready. Yeah. So go ahead, Priyanka.
So let me share then my screen.
Yeah, you can share.
Can you see my screen?
Not yet.
Yeah, now?
That's coming.
Yes, okay. So this is IUCAA Stellar Group. I'm representing this group. And in our group, there are other members. This screen. So other group members' names I have included in the submissions table. The first experiment is verifying inverse square law. To do this experiment, I have used one cell phone and a tablet, and I have done it twice. Once inside a big hall, inside a corridor in a big building, and the second time is outside in a small children's park. So there I have used two plastic stools. So my observations, the first observations was like this. This is the distance. First, I have kept the tablet at 5 centimeter distance. And before doing that, actually, since I was using the mobile hotspot, so I have removed SIM cards, and both tablet and the mobile phone were fully charged. So while I have got these results, I have tried in different places. First, after 5 centimeter, then 10 centimeter, then continuously up to 10 centimeter distance separations I have measured the power, and then a slightly increase, then up to 450 centimeter I tried inside the room. Then this is the graph that I have got it. And base fit line I have drawn, and from the base fit line I have found that slope is minus 15.515, and it is not exactly giving this what theory is saying. Say inverse square law. Then I tried it in the outside that is in a open small children's park. So it is surrounded by trees and not much reflecting other surfaces were there. So there also I have tried, and these are a little bit fluctuating. Our results were a little bit fluctuating. And from this base fit graph, when I have tried to get the values, then I have found it is minus 20.0093. It is almost coming near to the actually what theory is predicting, that is intensity varies inversely to the square of distance. In the second experiment, this inside a room I have done it. This is the experimental setup. This is one galvanized iron sheet with zinc coating is there. And this is the mobile phone that in a thermocol I have kept it, and this one is the tablet. So from the mobile phone I have used as an antenna, that is hotspot I have used. So from the mobile phone, exactly at 40 centimeter, I have kept the tablet. And first the refractor was kept at 5 centimeter, then 10 centimeter, then means in steps of 5 centimeter, slowly I have moved the reflector. And I have got this result. Up to 90 centimeter we have measured. And when we have plotted in this power versus distance curve, then now we have got this graph. And it's the height here. It was first peak found at 18.82 centimeter, and first this minimum we have found at 26.20 centimeters. So means our group interpretation is that we can use this type of a reflector, just like a mirror. Means we can use it. Suppose there is a problem in the line of sight of a signal, if there is obstacle something, then we can use this type of reflector, just like a mirror. That's all. Thank you.
Yeah, maybe a comment on this last, while the transparency, the slide is on the view. The sampling that you have done, steps of 5 centimeters, is already comparable to or wider than the scales on which you are expected to see the variations. Okay. So you might have missed many variations. So this is sort of an undersampled version of it, coarsely sampled version of it. If you would repeat the measurements, even up to about, let's say, 20 centimeters, carefully going at 1 centimeter step, it would reveal the real nature of the variation that one was expecting to see. Okay.
Means 1 centimeter distance.
Other measurements do help, but you will find that the crux of the variation is missed to be captured because of the coarse stepping.
Okay, I'll do it again. Do it. Thank you.
Ashish has some question. I think why is the channel frequency changing? Can you bring up the table that you had just before?
Oh yes, yeah. So while doing this, I have done every time. Means I used to switch off this hotspot. Means after every measurement, I used to switch off the hotspot, because I have noticed that if I don't do that, then there actually in the receiver, in the laptop, in the tablet, it actually shows the previous result only for long time. So that is why I used to switch it off. And when I at a separate distance, when I take it, then channel frequency slightly varies, but it is within the bandwidth. It is 2.4 gigahertz. You can say it is within that bandwidth.
Yeah, I agree. The frequency change that is seen here will not matter for the calculation.
Yes.
But it's interesting that the band probably changed, right? It's in the same.
Almost in the band, within that band, you can say that.
Each time you switch on, it might have selected. So that's the price for switching on and off. Each time it would try to select the free band, right, within that bandwidth. Okay. One thing I noticed is at least the appearance in the photo, which is that it's all being done on a big table.
Yes.
Right?
Yes.
Okay, so that might have might play an important role in the way you would see.
Okay.
Your laptop, the radiator laptop is not raised enough to get the benefit of the reflector size. If it will be ideal if your the hotspot location is roughly at the center of the reflector, so it uses sort of that more uniformly across.
Okay.
So that's one possible improvement you can do, and probably raise both these things a little bit from immediate reflections. Although if it's a wooden table or something, it wouldn't do so much harm as a metal piece, but it will have an effect which might influence some of your measurements.
Did you check what was the power at the receiver end without the reflector? You just did
without the reflector.
Without reflector.
That I missed it, but the first case I have tested, but I have not noted.
May not be for observation, just for the sake of the clearness and why we are doing this experiment, why we need a reflector.
Okay. I have not.
Maybe you could do that.
Okay,
maybe you could do that.
Sure.
So we'll get to know what is the effect after, why we need to place a reflector at the back, and so what is the advantage of it.
Sure, I'll do that. Thank you.
Anything else?
That's all. Thank you. Can I stop then sharing?
Yeah, you can stop your screen sharing.
Okay.
Thank you. Yeah, any students? Still, I didn't get any message from the student side. Anybody wants to share their thoughts on the experiments?
Question, Sachin?
Yeah. Sir, yes, just now the Priyanshu sir mentioned about the experiment. He said that when I just turn off my hotspot and then take regular readings, that what I observe also, when I was doing the first experiment of the radio astronomy, I put the reflector, and when I was trying to increase the distance, I didn't observe any frequent changes, or it used to drop suddenly. But when I just doing on by going just turning off the hotspot, and I measured again. Then after that, I got the proper reading. So I did the same thing for the both experiment and got the same reading. If I start if I doing continuously, I'm not getting the same reading. So that method really works. And that Wi-Fi analyzer, that app also didn't work for me properly. So I installed a different Wi-Fi monitor or something. 2 apps I tested, and I got the proper reading. So I just want to add into that.
Yeah. Okay. Thanks for that information. It looks like some of these sets do not respond to the changes in the power immediately, and they probably get stuck on.
Yes, I took time, but as the time increases, it doesn't respond, or it shows the same reading of previous reading what I used to measure. And here he's shown that he took that very small distances, but I didn't observe any readings in the small distances. Like I started from 120 centimeter. They about 100 meter. I got the observations from around 100 centimeter, up to 480 centimeter.
Mm.
I didn't observe any drop or even small drop.
I think you will not. This is which experiment? The reflector experiment?
Yeah, sir.
Okay, so I think you were already at such a large distance.
Yeah.
Okay, that the this is the reflector distance or
receiver distance. I'm talking about. That reflector was steady at that time.
Okay. No, so which one? What was being changed?
I'm talking about distance. Yeah, I'm talking about the distance.
Okay.
So I was changing the receiver. I was increasing the distance. So there I observed that it was not changing initially at very small distances. So I started measuring with very large, 100 centimeter. I started with 100 centimeter and gone up to 480. I observed same thing in both of this experiment. In that reflector part where I used a mirror surface and in non-reflector part also.
I see. Okay, that's a little strange. We need to understand what.
But I got the result. But I got the result. Yeah. Okay. At last, after 300, the decimal dropped suddenly. It was constant, around it used to drop 7 or 6 decibels. And then after that, after 300 centimeter, it started dropping around 11 or 12 decibels.
Right. I think Ashish is basically commenting that it takes about 30 seconds for things to settle.
Yeah. Sometimes more than 30 seconds also.
Yeah. I observed that. But after waiting for around 30 seconds or 1 minute, it used to go to the previous reading. If I observe initially 31 decibel drop, then if I wait for another 30 seconds, it takes me to the previous reading of minus 28 decibels or minus 25 decibels.
Yeah, that's a little peculiar. Yeah, it may have been something specific.
Or what we can do is putting the that barrier, a wooden pad in between that. That also changes.
Hmm.
Okay, so that.
Thanks for mentioning this. Yeah. And I mentioned the tool that you used in your report, which might be beneficial to others as well. The other tool.
Okay, thank you.
Thanks.
Oh, yes, there is another hand raise. So, Yuvraj, do you have anything to add? You can unmute yourself.
Am I audible?
Yes, Yuvraj, go ahead.
So the same was the case with mine. While seeing the presentations here, all the readings were taken at an intervals of centimeters, whereas while I tried here, I had to move every meters to find the shift to be significant. I used the mobile app that has been prescribed, and it took me meters to identify. And the fact that the app not being responsive for the change that it has displaced, every time I had to come out of the app, close it, and again switch it on and do it in such a way. I just wanted to add it. That's it.
Yeah, thanks for mentioning. Thanks, looks like a more common problem than we would have imagined. So we would certainly get educated on that as well as a possible precaution with some apps and some devices, I suppose. Yeah, thanks for mentioning that.
The next presentation is by Priyanka Patel. So, Priyanka, just a second. Yeah, Priyanka, you should be able to share your screen and you can unmute yourself.
Hello, sir. Can you hear me?
Yeah, we can hear you, Priyanka. So,
sir, is my screen visible?
Yeah, we can see your screen.
Okay.
We can start.
Yeah. Good evening, sir, and all the participants. So we're going to present on the study of radio astronomy for 2 different setups. And as I'm a member of Group Sun A Star. Okay, so there are total 8 members in our group. who actively participate in this. So what we basically did is we divided these whole 2 experiments in group of 4. So this is the basic general experimental setup for the reflector one. So as it is, we have also taken it from the PDF itself. So I'm not going in detail. Now, this is the experimental setup for the reflector, which we did at our home inside. So we took the aluminum foil as a reflector and the phone over here and a laptop. So this phone was our transmitter and this was our receiver. So the distance between this, the transmitter and the reflector, we kept minimum, that is 1 centimeter, and then we increased it in interval of 1 centimeter. And the receiver, then the power was measured at was observed from the receiver side. So this is our first observation table. This is a D in 1 centimeter. That is the distance that we varied between the reflector and the transmitter. And then we actually noted the total 9 powers. And then we took the average of it. And these are the final P average that we got. So the power, and basically the distance between the transmitter and receiver, we kept it as 90 centimeter. And then we carried out this whole observation, and this is what we got. So this is our final result of experiment number 1. So on the x-axis, we plotted the distance of the reflector in centimeter, and on the y-axis, the power in dBm. So the black curve over here, it shows the original fit that has to be there, and the yellow one shows our observed points. So then we use the polynomial series to fit our curve with the original one, and we found out that the root mean square error was actually about 0.977, that is the chi-squared fitting with it. So it came that it was very well coinciding with the original result. And then we find out one maxima, which was about 4.4 centimeter and 2 minima at 1.8 and 7.6 centimeter. Then this is for the experiment. This is experimental setup for the second part, that is inverse square law verification of this. So here we took one laptop and phone, which was carried out in our balcony, and this is the measurement tab, which is showing the distance between both. So here this was a receiver and the phone was our transmitter. So when we started from 50 centimeters. So this is our observation table. So in intervals of 20 centimeter, we tried to increase the distance between the transmitter and the receiver. And correspondingly for each distance, we took 3 powers, and then we took the average of it. And this was the final power that we observed. And just for the calculation purpose of you, we wrote the positive power and all, and then we did the log of distance and the log of power, and this is the final reading we got. And then we plotted this the last 2 columns in the Excel sheet, and then we got this result, which very well actually verifies the inverse square law. That is, as the distance increases, the power was actually decreasing. So this is, and we got the very well fitting of the observation table, observation that we have done with the original one. So yeah, thank you so much, sir. And these are participants list, which actively participated in this. Yes, sir, I'm done from my side. Any
Thanks,
questions?
Priyanka. Any comment, Desh?
Yeah, I think your first big table for the reflector experiment,
yes,
you had a series of measurements done.
Yes, sir.
And then you mentioned that you took some kind of an average across the various measurements.
Yes, sir.
Some of those measurements look very different from the rest of them, and you might want to not include them in the average.
Yes, sir.
So you might want to look at it critically.
Yes, sir.
And the second comment is about the appearance and the distance of the reflector suggested that you might be working at a higher frequency. Was
Yes,
the
sir.
frequency of 5 gigahertz relevant or 2.5?
Yes, sir, it was 5 because actually sir, this was the part which was carried out by other participant of my group, and I was dealing with the inverse square law. So yeah, he did on 5 gigahertz. Sir.
Yeah, so it shows, maybe it's worth emphasizing.
Yeah.
Because the scales on which the ups and downs will be seen will be different from what people using 2.5 gigahertz would be seen.
Yes, sir.
Okay.
And sir, one more thing we noticed that when we were going above 120 to 130 centimeter, like in our previous like the presenter who presented his work, the same thing we were also observing. Then that as we were increasing 120 to 130 centimeter, a lot of distortion was coming. So yeah, so we just kept a distance of 90 centimeter, and then we carried out the whole experiment. Yeah.
Yeah. So my comment that I made in the previous, the first presentation holds good here as well, that the sinusoidal behavior is expected to be seen in the linear scale on the y-axis.
Okay. Okay, sir. Okay, sir.
Of course, for small changes, first order linear changes will be seen. But it will be better, particularly the zeros or the lows can be better represented on the linear scale.
Yes, sir. Okay, sir. We'll do that, sir.
Abhay has some comment on the chat box, I think, or Abhay, did you have some queries or comments?
He's asking why polynomial fit.
Yes, sir. Same thing actually. The expected fit is either cosine or sine. So I was wondering why there is a polynomial fit.
Would you like to answer that, Priyanka?
Experiment.
Yes, sir. Can you just, sir, give permission to my partner who can answer it really well, sir, because he did the whole thing. So can you just give permission to Tamal Sarkar? But if you have any question related to inverse square law, then I can definitely give the answer.
Yeah, Tamal, you can unmute yourself.
Sir, can you hear me, sir?
Yes.
Yeah, we can hear you.
Actually, for this purpose, actually, what I have done, I haven't considered the cosine. I just started with the polynomials of second degree, and I try to increase third degree, fourth degree, 5 degree, and ultimately I have seen that when we go to 6, then the fit is good, and after that the fitting is not changing. So I have gone in that method in Excel.
Yeah, you might try the linear scale on the y-axis and then try a sinusoidal fit, which might do much better.
Yes, sir.
Okay.
Okay.
Okay, any other comments? Okay, if no, then we'll move to the next thing. Thanks, Priyanka.
Thank you, sir.
So before we'll move to the next presentation, so I request everyone please turn on your video cam. So we'll take a gallery shot now. We'll take a small break from the presentation. So we want to take this gallery shot before the end of the session. I request all the participants, please turn on your cameras. Prakash, Abhay. Mahadev, Gitika, Ishita, Hari, Deepa, Nilesh. I request all the participants turn on your cameras. Thank you. Saike, you have taken? I have also taken.
Yeah, Jameer, I also took. Yeah. So.
Okay. Great. Thanks, everyone. Now you can turn off your cameras. We'll move to the next presentation. So the next presentation is from the astrophysics group, Abhijit Das. Is Abhijit here?
Okay.
Yeah, Abhijit Das.
Hello.
You can
Hello.
speak.
Can you hear me?
Yeah, I can hear you,
Yes.
Abhijit.
The thing is that I have not actually prepared a PPT presentation like others have done, but I have my graphs there which I can show.
Yeah, no problem. So maybe you can show your graphs and you can describe it.
Yes.
Just a second. Before that, I just want to announce the next presentation is from the Sagar Biswas from General Relativity Group. Yes, Abhijit, go ahead.
Okay. Now, the thing is that like everyone has been saying, I also performed the experiment many times actually. Using different sources, like I tried with my mobile phone. Then I saw a big, fluctuation in the readings. So the fluctuations were the wild fluctuations, kind of. So I did it in my room only because I could not go to any, outdoor location. Then finally, I performed the experiment using my Wi-Fi router, which I obviously have disconnected. And then I could get these results, which are also not very good, but still I'm showing this thing. Okay, is it visible?
Yeah, we can see.
Okay, so this is the reflector experiment graph, and I have plotted it in origin. So, okay, so let me. Okay, so the the data that I have taken, these are it is shown in the table alongside. And when I plotted, and this is just I mean, this is no fitting. It is just I have joined the. I mean, I've drawn a line and scatter plot. So this is the shape that I've got. So it's showing some variation, but so this is the thing. Actually, we are trying to, or we are planning to repeat this again to get a better result.
Yeah, you might want to go to slightly shorter distances than you have gone.
Yes, so the minimum distance that we have gone is 5 centimeters from the Wi-Fi router, because actually we have those wire plugins.
No, I understand. There might be difficulties associated.
Yes, we could not go closer to 5 centimeters.
Yeah.
So this is the thing.
Yeah, what you can do is if there is a way to turn the antenna at some angle.
Yes. That that can be done.
Then you might be able to approach the backside better.
Yes, sir. So
yes, there might be a peak that is yet to be seen at meters.
At closer distance, right, sir?
Yeah. Yes.
Yes.
So the rest of it doesn't look unreasonable.
No, actually, there are many points to the right of this graph which are actually more or less flat, as you can see from the value. So I have truncated it at 15 centimeter. So I have actually gone up to 40 centimeter.
Oh, I see. And then you don't see much variation. Is that what you're saying?
No. Slight variation is there, but not much. So.
Okay.
Is it okay, sir? Then I can go to the next one.
Yeah, please go ahead.
Okay. So the inverse coil law one, again, it is okay. These are the data points that we have gone for from 25 centimeter to 3 meters, and we have got this plot, and we have gone for a linear feet, and this is we have got a slope of 2.4, around 2.4. So we have found that a lot of points are away from the feet actually, towards the larger values of the distance.
Yeah, your drop in power is not as much as expected. You have only about less than 3 dB power change for more than a factor of 2, or roughly a factor of 2. No, more than that. Almost a factor of 10 change in the distance. So it should have been, typically about 20 dB change.
Actually, this particular experiment has taken a lot of time, and I have noted down a few comments that, as in the Jameer sir has mentioned, to share our experiences and attempts. Yes. So the thing is that since I am doing in the room, I don't know whether I am correct or not. I mean, in my room there are a lot of these metal almirahs. So maybe these are reflecting and interfering with this. So that is one thing. So I could not eliminate that. And what I felt is that this is an experiment that should be done in open space, without any disturbances nearby. And one puzzling thing that I have that I noted actually, that I have done this experiment in a room, and I've got this. You can see this data at around at around 2 meters, say 225 centimeter. We have got a power of -70. It is in the same room, in a line of sight distance. Now, since that is my Wi-Fi router, and I took the laptop to another room, and when I actually saw the reading in my laptop in another room, I got it 54, -54. So that was very puzzling. In the same room, at a line of sight distance of 225 centimeter, I am getting -70 power, but in a next room, I'm getting -54, and that -54 was very steady. So these are some of my experiences that I wanted to share.
It's interesting that in this table, there is significant variation seen. Okay.
Yeah.
You see large variation that is not reflected in your plot. Probably the plot was made with some other data set.
No, this one only.
Okay, then it's strange. The B column doesn't reflect in the way.
No, it is actually this plot, because B is the power. So I took the log of power and multiplied by 10.
No. Okay, so that number itself is in log. It's already log of the power ratio.
Yes.
With 1 milliwatt. Okay, so no further log needs to be taken. Okay, so that's probably the
-71. Okay,
yes, the entire column of power measurement is already log 10 times the log of the ratio of the received power to 1 milliwatt.
Okay.
No further log needs to be taken.
Oh, then I
okay.
Then I have made a mistake. So,
Yes.
Let me just repeat this. So I should plot this number against log of distance, right?
Correct.
So distance, I'll have to take the log of distance, right?
Correct.
And I'll have to plot these numbers against log of distance. Is it that?
Correct. Because these are already in log units. I mean,
okay. No, what I did, I took the log of all these in the B column numbers and then multiplied by 10.
You have to also take modulus of it, right?
Yes.
Log of negative.
Yes, so I removed the negative sign and then took the log multiplied by 10.
So you can ignore your last column, which is what is giving you the results that look weird.
Yes. Okay.
So you might have good results. Just take the values as measured in EBM as already the log values.
Okay. Thank you, sir.
All right, thank you.
Okay. Can I stop sharing?
Yes, I suppose. There are no further questions.
Right. Another thing that I wanted to say actually regarding that reflector experiment, sir, we must be very careful, I think, to place the reflector exactly vertically, and that is a very difficult thing in our home conditions. That is what I felt actually.
Yeah, even if it's not vertical, as long as you make the receiver be along a line perpendicular to the reflector, it would do the job. So that might be achieved by simply raising your receiver, okay, to a convenient height, so that it's along the line perpendicular to the reflector surface.
Okay, sir. So I got it. I mean, while
to maintain is the perpendicular nature of the line of sight.
Yes.
The reflector.
Okay, sir. Thank you, sir.
Thanks, Abhijit.
Yeah, there was a comment in the comment box. Let's see what that was. With narrow radiation patterns from the internal antennas and associated side lobes, I wonder if it's reasonable to expect radialism. Yeah, so my comment is even if there is a finite, directivity, depending on the complexity of the antennas used, you would still get the same results on the bore site. Okay, it is independent of the other lobes, so to say. We are concentrating on the main lobe response. If that happens to be the only lobe, of course, then visualization is simpler. But you would see these changes with the distance as well as with the reflector distance much the same way, even along any one of the lobes, particularly the main lobe. Does that answer the question or objection, Matthews?
Yes, it is. Okay, shall we move to the next presentation, Desh?
Yeah, I guess so.
Okay, I request Sagar to present your work. And next presenter is Mr. Arun Kumar from Star Formation Group. So be ready. Yeah, Sagar, you ready?
Yeah, I'm trying to share my screen. Okay, I'm sharing. Can you see?
Yeah, we can see your screen.
Okay, so this presentation is from General Relativity Group. These are the member of the group. So let's show you. So here we have written the same thing which was written there. So inverse square law is like, if I0 is the power, then it will fall as IR will be proportional to 1 by R square. So in this experiment, we use two smartphone, one smartphone as a source, radio source, and another smartphone as a radio receiver, the receiver of the source, and the frequency of the source is 2.4 gigahertz. We use that, and in the receiver end, we use Wi-Fi analyzer to measure the strength of this source. So there, the power is given in dBm. So initially, I did not know what is dBm. So then I find that actually dBm is power expressed in log. So I mean, if you take the logarithm of the power, and the power unit is in milliwatt, and you have to multiply with the factor of 10. So this is how the dBm is expressed. Well, now let me show my result here. So the first experiment, inverse square law, the result is here. So we keep changing the distance of the receiver at this distances, and the power we received this. And the plot is shown here, which we try to fit it with a linear curve, and the data points are slightly bit away from the fitted curve, and this fitted curve have the slope of -20, and the straight line is expected here because in power have been expressed already in log, and distance we have converted into log. So this is log curve. So the slope of this curve should be -2. But we get the slope is -20, but as in this case, the power has been multiplied with a factor of 10. That's why we get a factor of 10. So in converting, if we have not multiplied with a factor of 10, then we have obtained the slope of -2. So this verifies the inverse square law, I think. And there is another result from another member of our group. This result is shown plotted here. Although I did not put data, but the result is this, and the slope came to a -19. So this is the slope is very much near to, I mean, in -2. I mean, so this both this verifies the inverse square law, I think. Okay. Next, let me move to the second experiment. So here, the reflector, we know the importance of reflector. Reflector increases the directionality, and those things are already written. So from the reflector, actually, when we place a reflector, the signal obtained from the source and the signal which is reflected, emitted from the source and reflected back from the reflector, for that those two sources will actually interfere, and they interfere constructively if the phase difference is of the order of wavelength n lambda. So if the path difference is n lambda, integral multiple of lambda, and they interfere destructively if they are half integral multiple of lambda. So and the reflection will also put an additional phase shift of pi, and this phase shift we have converted into path difference, which becomes so by this relation between phase difference and path difference. So there we find that this pi phase shift will equivalent to a path difference of lambda by 2. And the source, again, we have used the same 2.4 gigahertz and having the wavelength of 12.5 centimeter. We have calculated this. Okay, so now here is our result. So we change the source, sorry, we keep the reflector fixed, we move the source by 5 centimeter, 0.5 centimeter separation. So these are the result we have obtained, and the plot is shown here. And the plot we have tried to fit with a sinusoidal curve. Yeah, so we have found the maxima at 2 centimeter and at 10 centimeter, and the minima at 6 centimeter. So we have another result. So another student have tried this experiment. So and this is their result, and they get maxima at 5 centimeter and 15 centimeter and minima at 11 centimeter. Okay, so now to understand what actually we should expect, so for that we have added discussion slide. So where is written, if D is the separation between the source and the reflector, then this will introduce a path difference of 2D, and this implies the condition of maxima will be 2D plus lambda by 2 equals to n lambda. So this lambda by 2 is the additional path difference which will be introduced due to reflection. So on solving, we get D equals to this half n minus half lambda. And if we put the value of things we have used, that lambda with the value of lambda, and for first maxima we put n equals to 1, then we get that first maxima occur at 3.125 centimeter, and the second maxima obtained second maxima. So in second maxima we put n equals to 2. There we find it should be at 9.375 centimeter. Similarly, the condition of minima, so it will be 2D, the same thing, 2D plus lambda by 2, and this should be equivalent to half integral multiple of lambda, so n plus half lambda. So again, solving D, we get D equals to n lambda by 2, and for n equals to 1, if we put n equals to 1 and value of lambda, then we get the first maxima is expected at 6.25 centimeter. So now we compare the value what theoretically expected and what we obtain. So first maxima should occur at 3.1 centimeter, but we get at 2 centimeter, and another experiment got 5 centimeter. First minima should obtain at 6.3 centimeter. We obtain at 6 centimeter. Another one experiment obtain 11 centimeter. The second maxima should be obtained at 9.4 centimeter. We obtain at 10 centimeter and 15 centimeter. So that there is certain difference from the theoretical value. So we guess this might be due to that we did this experiment in a closed room, and the reflection from the floor and side walls might introduce some error. So this I thought, I mean, this might be the reason for this difference. Well, so that's all. Now,
can you just show the results from Urmila's experiment just once more?
Yeah, this is the result. I mean, I did not show the data point.
Okay. I'm just trying to see whether there was any. These are finely sampled points, so one cannot suspect any variation being missed to be recorded.
Is the wavelength the same for both the experiments?
Yeah,
the wavelength is same. When if the wavelength is same.
Yeah, this is very, very strange. There is systematic behavior, but on the scales, which imply more like three. What is it? This looks like quarter, right? If 5 is quarter, 20 centimeters. looks more like appropriate for 20 centimeter wavelength.
Yeah.
I thought the both wavelengths are different, but I'm surprised to know they're operating at the same wavelength.
Yeah, maybe I ask Urmila if her wavelength is 20 centimeter or not.
Because the behavior is not erratic, it's quite systematic.
Yeah.
And so actually one becomes more curious about the frequency, as like I said, whether it's actually same. It's unlikely to deviate from these normal standards, but who knows? One of these early sets, okay, might have the provision for a lower frequency. We don't follow the technology.
But in a smartphone, a lower frequency is there. I mean, lower than 2.4 gigahertz.
I don't know. That's what I said. I'm unaware of it.
Yeah.
But these results seem to suggest as if the behavior is for a lower frequency.
Right. So initially I thought might be this is different, but I realized that another frequency is 5 gigahertz. But for 5 gigahertz, wavelength should be much lesser. So it should not be that. So that I realize. I don't know. Other.
This is interesting. We will need to probably repeat this experiment and probe a little more on exactly what is happening. But yes, it does attract as a. Okay, so Ashish adds that none of the Wi-Fi's go below 2.4 gigahertz.
Right. Or maybe.
So here, even questions like how the distance was measured would become relevant. Sorry for that, but
the distance was measured how? Yeah. So I measured the distance with a tape. I don't know how they measured.
Yeah, there could be systematic error in that measuring the distance.
It looks more systematic effect of something. We do not know yet what. Okay. But it's not some random situation leading to.
Maybe with the same setup, so they can repeat and they can say whether they're getting the same.
Yeah, so we are all assuming that this is a distance perpendicular to the reflector surface, okay, of the radiator. If it was at any other angle, then of course distances would appear large. They would appear to change over the range that we see, right? And then everything might fit in.
Maybe one suggestion is that they can repeat the experiment with the same setup and see whether they get the same result.
Right. They can even repeat it with 5 gigahertz if there is a choice to see that things do change accordingly.
Okay. So.
Okay. Thanks, Sagar.
Thanks for bringing this up as a very peculiar case.
Okay. Thank you very much. So I can stop share now.
Okay, you can stop sharing your screen. So now I request Arun Kumar be ready. So before that, I just want to know, is any student is interested to share their experience? So please drop a message. So I didn't hear anything from student side, from summer school. Okay, Mr. Arun Kumar, you can start your presentation. And the next presentation is from Cosmology Group. Sukanta Dev, be ready.
Okay, so good afternoon, everybody. Is I'm audible?
Yes.
Hello? Yeah, okay. So I'm from Star Formation Group, and these are the names of my group members. Uh, Star Formation Group. So, in first experiment, that is verifying the inverse square law using Wi-Fi signal. So, in this experiment, as a hardware, we have taken two smartphones and one smartphone with hotspot, which is as a transmitter, and other we have make it as a receiver. And uh, receiver is for the purpose that it can receive the strength of the signal that is transmitted from the um, mobiles with hotspot or transmitter. So software is that is a Wi-Fi analyzer, which is installed in receiver, and procedure is that when the signal transmitted from transmitter that was received in receiver, and we uh, how much strength of signal is received in the receiver, and what is the distance. So we measure the strength of the signal with respect to the distance, and these are the observation tables, and we have observed the uh, strength of the signal in the receiver at a particular interval of distances, and that is 5 centimeter, 10 centimeter, 20 centimeter, like this. And by using this data, we have plotted a graph between distance and log of power. So this will perfectly verify the inverse square law. So here in this diagram, in plot, we have shown that with respect to distance, the strength of the signal is going on decreasing. So what I have understand by this experiment, that whatever may be the distances or whatever may be the interval, I think it does not depends upon the interval of distances, or what may be the distance that it is smaller or it is larger, but inverse square law can be perfectly verified for any distances. So if we take any distances, and at that distance we can record the strength of the signal received or power, and plotted a graph that can verify the inverse square law. uh, uh, that was already shown in the electric field and magnetic fields. So next experiment is effect of putting a reflector at the back of the antenna. So in this also hardware is same, but what we have did that in first mobile, which act as a transmitter, in the back of it we have put a reflector. So that reflector is kept perpendicular to the plane, which consists the receiver, observer, and the transmitter. So by keeping the perpendicular, we get the data which is verified, which is varied in a particular manner. So these are the uh, diagram for back reflector. Here reflector which is in the back of the mobile, which reflects the data, and one mobile which is kept perpendicular to the reflector, and that transmit the signal. So both the signal, one is transmitted and other is reflected. Both the signal we received as a strength of signal in the receiver. And what I get from this, that in this figure, the signal what we received, uh, um, and we plotted that diagram, and the data which is received, we have not set at any interval. We just taken the data at a distances 1 to 3 centimeter in centimeter. So it can be taken at any point, 1 or 0.5 or whatever may be the distances. It does not depends upon the distance, I think. Maybe it does not depend upon interval. It depend only on the distance. So by taking the distance and versus signal received, we have plotted again a plot, and what we get, that the signal is well verified with respect to the distance, and a sine curve, which is sine like curve is shown in this diagram, and this shows that the half part what I understand by this experiment, that the strength of the signal transmitted and the strength of the signal that is reflected back from the reflector, so this both has the same strength, but maybe the signal which is reflected have to decrease its strength a little bit. It may be decreased, but what I get from this diagram, that signal is not decreasing. It's look like such that the signal transmitted directly to the receiver or from the reflector both have the same strength. That's why we are getting a sign like shape in as a result. So these are the observations what we have did. So, okay, thank you. Hello.
Yes.
Hello.
Yeah. Thank you.
Okay. So these are our plots for back reflector.
Okay, at what wavelength you were operating? 2.4 gigahertz?
2.4 gigahertz. 2.4 gigahertz, sir.
Okay.
So, but sir, I think this sine curve maybe it may be more varying. I think.
I think first, just plotting it on the linear scale along y-axis would show better correspondence with the sinusoidal behavior.
Yeah.
Okay.
Okay.
Particularly the low going points will roughly appear similar. Okay?
Yeah. Yeah.
Because sometimes they could, go sharply low, but that just means that they're going closer to zero.
Yes.
And each one of these points itself has some uncertainty, which we haven't yet admitted. So one will have to take that into account.
But sir, I have did this experiment in a rough manner, like that. The hotspot mobile is somewhere at distances of 600 meter or 700 meter, and I have installed my software in mobile, and that is 700 meter long from transmitter. Then also I have taken the data, recorded the data, and plotted the graph, and that is well. I think it is well graphed as a sine curve, and it well defines the result, I think.
So when you're saying when you put your receiver farther,
means I have detected the hot spot. I know, matlab somewhere is there at anywhere whose hot spot is on, and I have kept my mobile at a very long distance, so it is receiving the signal. And by that also I have plotted the same graph as a sine curve, and it shows the result.
Yeah, sure. I think when you're very close, you will begin the near field effects, which might mask the true behavior that you're supposed to get just of the reflector distance that you clearly see once you're sufficiently far away from the source. In addition, you might consider plotting the y-axis values linear scale.
Yeah.
Okay. Thank you, Arun Kumar.
Okay. Thank you.
So we'll move to the next presentation from Cosmology Group. Sukanta Dev, so are you ready with your presentation? So Mr. Arun Kumar, you can stop sharing your screen. Yeah, thanks. Is Sukanta Dev is here? Sukanta Dev, you can unmute yourself, your co-host now, and should be able to share your screen.
Yeah.
And next group is galaxies. So Homnath, so be ready. You can start.
Yeah, I can start. Can you see my screen?
Not yet.
Yeah, 1 minute.
Start.
Sorry, 1 minute. One minute.
Yeah.
Yeah, okay.
Yeah, we can see your screen.
Okay. Yeah. Okay, so we are in the cosmology group. So the group members include myself, Subhash Kumar, Srilekha, and Vinuta. So first experiment that I'm going to explain is about verification of inverse square law. So in this experiment, we have used a smartphone with hotspot on and internet data off as a transmitter, and the frequency is 2.4 gigahertz, and then a laptop installed with Ubuntu 20.04 as receiver, and then measuring scale and tools to put the transmitter and the receiver at the same height facing each other. And for collecting the data, I have used that simple script that I have used a script for 1,000 iterations. And so first of all, the receiver and the transmitter are placed at a fixed distance. And using this above script, the power values for 1,000 iterations are directed to a file named Wi-Fi_test.dat. And from that file, the mean of the power values and the standard deviations are noted down from the data thus generated. And the above steps are repeated for 10 to 11 different values of fixed distances for varying distances. And finally, the distances, the power values, and the error in the power values are noted down in a file for further data analysis. So these are the table of observations. So I have kept distances at around 15, 20, and then sometimes 40, 70, 90, and I have gone up to 230 centimeter. And these are the power values that I have got. And since I have taken for each of the distances, I have taken measurements of 1,000 power values, and that's why I could get a mean. And the power value that let's say for a particular distance, let's say for 15, I have got the mean value of power is minus 18.359 with a corresponding error 0.480. And this is basically this is repeated. This is repeated because sometimes as I have seen that once you change the distance, then there is some kind of fluctuations, and these fluctuations are basically I had to wait for some time for a few seconds till the fluctuations basically come to normalcy. Fluctuations become somewhat stable, and this is basically judged by looking at the error values. So I have to just run the code, and every time keeping the distance, let's say fixed for 15 centimeter, and then wherever I got the minimum error, so I used to take that value. And similarly, same procedure is followed for every distance of measurements, and this is a table of observation. And finally, the distances are plotted in the log scale, and the power values already it comes in this format, tan into log power divided by 1 milliwatt, and so. The trend of the data like a linear plot, straight line. So therefore, I fitted a straight line to that data, and the fitting curve is y-x is equal to a0 plus a1x. And when the data is fitted, then I got the intercept equal to 8.529 plus minus 1.582, and the slope as equal to a1, which is equal to minus 21.997 plus minus 1 to 3. Now, next is the effect on signal with a reflector at the back of the antenna. So again, we have used the same setup, and smartphone with the hotspot on, and internet data off as a transmitter. Laptop installed with Ubuntu 20.04 as receiver, and the smartphone is acting like a radio signal. It's a frequency of 2.4 gigahertz. And reflector, in order to make a reflector, I have taken a white, cardboard, and then I wrapped it with an aluminum foil. And then for measuring distances, for keeping the transmitter at a fixed distance, I have used a scale and two stools to put the transmitter and the receiver at the same height, facing each other. And this is my log of observation, and every log of observation is associated with the error values, and the mean is basically the mean values are taken as a true value of power or at a particular distance of the reflector from the antenna, and the mean is, let's say, for the first observations, keeping the reflector at a distance of 2 centimeter, I measured the power value and then its corresponding error. So similarly, varying the distances, I got this log of the observations, and I plotted. I got these observations, and ultimately I could found that this is somewhat kind of a equivalent with kind of profile, and it's something like I thought that because I didn't take too much of many observations, and my observations were limited only up to 20 centimeter, and I found that it looks like almost some kind of equivalent with kind of things, and I measured. I tried to fit the data with a Gaussian with a plus some mean value around this Gaussian, and this is my result. This is what I have got, and the chi-square value is 0.71 in this case, and thank you.
Yeah, so at what frequency you're operating? So
it was 2.4 gigahertz.
It was 2.4 gigahertz.
Yeah.
And you didn't go for like further distance?
No, it's the other way. I think he didn't. They didn't go for fine enough steps in the distance.
Mm-hmm.
Okay.
Yeah.
You just are missed.
Yeah, I missed it. I think that I missed it. I have started from 2, 3, 5, 7, 9 like this. So maybe I could have
need to go finer, even if you go very far in the distance.
Yes.
Going finer will reveal the real nature of the variation.
Yes. Actually, I did it yesterday in a hurried manner.
No, that's fine.
So I'll repeat it actually. Yeah.
For the same reason, you're fitting that to a Gaussian or something like that is not physically motivated.
Yeah, it's not physically motivated. Yeah.
So we will ignore that.
But generally, any kind of sine curve can also be fitted with the sum of the Gaussians also. If it is even a sinusoidal curve, then it can. Yeah.
I understand, but right now the result itself
has
inadequacies, so it might be too early to even model it.
Yes. It will be too early to model it. Yeah. So yes, I have to repeat it in steps, so maybe 0.5 steps, so that I can. I
congratulated. You will have congratulated on another front.
Yeah.
A different front that is for caring to measure or estimate the error or uncertainties. Okay, and this is something that I'm sure will have a good message to convey to anyone who's going to do these experiments. That with the error bars put in or uncertainty being recognized, suddenly all the measurements are put in the correct perspective.
Yes. Yeah.
So that one doesn't overinterpret something.
Yeah.
Okay? So that's very good. You have to be congratulated for that.
Thank you.
Thank you.
Yeah. Thank you, Sakanta.
Okay. Thank you.
So you can stop.
Can I stop
sharing?
Yes.
Yeah. Thank you. So I request next group from galaxies. So Omnath, are you ready? Sagar, can you make him as a co-host and allow him to share? Omnath, you can unmute unmute yourself.
Yeah, okay, sir.
No. So you should be able to share.
Just a minute, sir.
So there are two groups who are not presenting today. So still, is there any chance you want to say or you want to present? So the group names are Astronomy and Group 10. If yes, then please let us know.
Okay. Sir, am I audible?
We can see your screen. Yeah, you're audible,
okay.
And we can see your screen and you can start.
Okay, hello everyone. I am representing Galaxy's group and actually this is our initial result. Actually what we are doing is we are trying to do our experiment individually and we'll post it to a forum, then we'll discuss and we'll sort out the results. So this is not final one. So I'll just show my initial readings. So the first experiment is verifying the inverse square law using Wi-Fi signal. This was carried out by our group member Prasanjit Paul, and I have taken the slides from for what he has shared. So the apparatus used is for hardware. He has used a Wi-Fi router as a transmitter and smartphone as a receiver, and the software he has used is Wi-Fi analyzer. And this is the result that he has got. So this is the we have plotted distance in the x-axis and the power in the y-axis, and we have got this perfect fit, means it seems little perfect. So this is the first result, and the second experiment that is to study the effect of putting a reflector at the back of antenna. And this I have done myself, and the hardware I have used is smartphone Wi-Fi signal as a transmitter and Wi-Fi and laptop as a receiver, and the software is used as WinStumbler for Windows. And here is the result. So here we have plotted distance in the x-axis and power in the y-axis, and we have got this plot. I have not fitted it perfectly, but I have just connected the data points, and I have got this result. So this is our preliminary result. So tomorrow or day after tomorrow we'll compile all our result and we'll discuss and we'll make a final report. So this is it for now. Thank you very much, sir.
So yeah, can you stop here on this result?
Yeah, sorry, sir.
No, we just want to have a look on this result.
Okay, sir.
So Desh, any comment?
Yeah, my same suggestion that for the reflector results, you will find it more instructive or more revealing to plot the y-axis values, the power values in linear scale.
Okay.
Which will show more, basically the constructive and destructive interference.
Sir, actually, this is in linear scale only. The power value, right, sir?
Yeah, so these are measured in dBs.
Yes.
dBs are already 10 times the log of the power ratio with respect to 1 milliwatt. Okay. So if you would convert that to, let's say, milliwatts or something, right?
Okay.
Or whatever convenient unit, it doesn't matter.
Okay.
So as long as it's in the linear scale, you would find the constructive and destructive interference would bear out much more nicely.
So in that case, if I plot this the y-axis in exponential terms, then log will get cancelled and it will be linear, right? Can I do that?
Pardon?
If I plot this in exponential term, then the log will get cancelled and I'll get linear. Can I do that?
Yeah. Basically, you are taking anti-log, right?
Okay. Yeah.
It's the same, operation in principle.
Okay. Okay, sir. Thank you.
Thank you, Amnath. So you can stop sharing your screen.
Okay, sir.
Okay, we are almost done with the presentation. So there were 8 groups who presented today, and we didn't get any response from 2 groups. Sorry, anyone is saying something? Desh, you want to say something?
No. Must have been background sound. Yeah.
Okay.
Jameer, the Star group has presented, right? That was.
Sorry.
Okay. The Star Formation group, they were sending messages, Arun Kumar Singh, but I think they have presented.
No, he presented. Yeah. Arun Kumar presented.
Yeah.
So the group names are Astronomy and Group 10. They didn't present it today. So these are the only 2 groups who left. So otherwise, all other groups have presented.
Okay.
So we are done with the presentation. Still, we'll give a chance to the summer school students. If they want to share something, please raise your hands. If no, then we will stop for this session. Yeah. So Ayush has raised his hand. Yes, Ayush. You can unmute yourself.
Hello, am I audible?
Yeah.
Hello, sir. My only question is related to like applying for the PhD program in IUCAA. Since I am a BTech background, but I managed to clear CSAR JRF in physics. But I haven't found any application forms from the past year in order to apply for PhD in astronomy and astrophysics. So I was wondering if there is any opportunity to directly go for the research work in IUCAA, or if there is any way where I can apply for the PhD that you might suggest.
Actually, Ayush, on Friday, although it has not been announced yet, there is a session planned to just discuss careers in astronomy. Okay, where all these questions will come up, and you're most welcome to participate in that session. I think we will. Okay.
On the upcoming Friday at the 4 p.m.
Yeah, at 4 p.m. slot. It's tentatively scheduled for Friday. I think Dipanjan Mukherjee, who's coordinating the whole thing, he's trying to put it together. So there will be soon an announcement on, pursuing your careers and courses further in astronomy and astrophysics.
Okay.
Okay.
Thank you so much, sir. Yeah. That was really helpful.
So anyway, I think it's been fantastic that so many of you have actually managed to, sort of get together, do the experiments at home in spite of the pandemic and all the challenges. So that's it's really good to see. And if you have any feedback on the write-up so that we can, make it more user-friendly, do let us know so that before we make it publicly available on the web for everybody to use, if there is something you think we can incorporate, then please do let us know. Desh, you want to add anything or say anything further? Or Jameer, Ashish?
Yeah, I just wanted to say that it is actually pretty a good feeling looking at the level to which experiments were done.
Yeah.
With the interest shown and the care taken to look at the details as well. And many of you who might be interested in pursuing it further might try several other variants of this. You might want to put a corner reflector instead of a flat reflector, and you might see a significant increase. Then noting that the directionality is influenced by this presence of reflectors or any other scatterer in the vicinity, you might want to move laterally, sideways, to see when you have this source with a reflector would have now reduced or higher directivity, reduce solid angle in which it's radiating higher signal. And you can move laterally and measure the beam width or the directivity. In principle, if you put corner reflector, the directivity might improve even further. Then on the other front, where we were worried about reflections from almirahs or other objects, balls, and so on and so forth. You can also use that and actually conduct an experiment equivalent of the Seacliff interferometer. That was a very famous experiment. So you might look for this keyword and see how a well-arranged reflection along the path before things reach the receiving antenna can produce interference, and you can get an equivalent of young double slit experiment or interferometry achieved using only one receiver. So that would have been additional experiment had we gone for more experiments. So you can certainly look up these and perform your own variants of it. And as Ashish, I think, has written in chat, you can try plotting the radiation pattern of the mobile phone antenna itself, with and without the reflector, and so on. So these are my suggestions. If you feel that you've got a mastery of making these measurements reliably enough, you might venture into other fun experiments, and feel free to innovate yourself on a variety of things. Basically, the essence of it is that any reflections or any other path propagation would interfere, and the constructive or destructive nature of the interference would lead to what the final result is.
Hello, sir. May I say something?
Yes.
Sir, as you have mentioned, interference experiments, can we do an experiment with two transmitters and look for interference?
Yeah, unless they are coherent sources, as you know from our optics.
Right? Yes, yes. Yes.
But you might do that in a way where we do how we do our optical experiment. We put a small. We first make them coherent or have a single source, and then have two slits or two openings.
Yes.
Okay. And then see the interference. That can be one way. But care has to be taken that these are indeed acting as a coherent sources. And of course, the apparent size of the source here is going to be much smaller, okay, in terms of lambda. Okay.
Mm-hmm.
So you will see that as a single coherent source. As long as you put the two openings sufficiently far away that they will begin to see some coherence. Okay. At shorter distances, the small changes in the symmetry, deviations from the symmetry might make them appear, at least phase shifted, if not incoherent.
Okay, so we can actually put a metal wall kind of thing, and in that wall we can make two holes. two slits.
Yes, you can do
put
that.
Put the transmitter behind.
Correct.
Okay, that will be interesting.
Of course, you can. You will also have other effects, and please don't be surprised by those, because the metal. Ideally, what we want to do is block the radiation. Yes. So you will find that while the other part reflects, and if it's electrically connected with the side that is also facing you, which of course it will always be, you will find that it will act as a radiator, additional radiator, and the collective response of the two is what you're going to see.
Oh,
okay. After all, like the reflector acted as a part of the source, right? And combined effect of it was seen. So as long as you keep all these things in mind, you will be able to interpret what you see more correctly.
Right. So very interesting. Actually, we can give these simple experiments to our students also.
Yes, that is the idea as well.
in this pandemic, I mean, with everything going online, I think this would be very interesting. Actually.
In fact, these were considered to be the sort of possible things that one can do without having to go to a specialized equipment.
Yes. Thank you, sir.
In fact, I would probably go a step further, Abhijit, that beyond what we and Desh have suggested, that if you can think of experiments to do particularly in this pandemic period, which are astronomy related, it would be lovely if you share with us as well. I mean, that applies to you, Abhijit, as well as others. And
yes,
benefit the larger community as well.
Okay, sir.
Okay.
We can probably stop now. It's nearly 2 hours.
We can stop, I guess. And I guess probably this was the last session from the experiment side, radio experiment or other experiment. So again, we'll meet in the other lectures. So anything you want to add, Desh, Sekya, or shall we stop?
I think we can stop. Homnath has hands up, so I don't know if it's an old one or a new one.
No, it's a newer one. Yeah, Homnath, you can unmute yourself.
Yeah, hello. Am I audible?
Yes.
So actually, regarding the same thing, actually I am also planning to keep this experiment with students because the usual experiment that we were doing during this because of this pandemic, it is not possible to do offline. So can you suggest some other experiment which you can give related to this, which can be done on online mode? Any other experiments like this means?
Actually, Omnath, what we are trying to do is, these are two of the ones which we had used during the radio astronomy winter school, and which, my colleagues Desh, Jameer, Ashish, Prakash, they have developed. We have actually trying to put in a larger set in our website, and if all of you all can actually contribute as well, that would be great. But it will soon be up of what we develop in the IUCAA website as well, so that you can have a look over there. But besides the kind of things which we are doing, there's also a lot of things which you can do using archival data from, SDSS or, Gaia, where they have actually put up nice sort of packages or to use their data and do simple experiments, which will be largely data analysis oriented, but it's something which you could do or students could do. But we will have a more complete description, hopefully in a not too distant future, a month or two.
Okay, sir. Thank you very much, sir.
Okay, I think then we can close now.
Yeah, we can close for today. Thank you, everyone.
Yeah, thanks a lot. Thanks very much.
Thank you. All the best.
Thanks.